deep into one of the weirdest puzzles in quantum physics. Seriously, it's a mystery that has had scientists scratching their heads for decades. How can one single particle act in two completely opposite ways? It's a story about two quantum worlds that seemed like they could never ever connect, until now. So let me ask you this. What if a particle could be the life of the party, drawing a crowd wherever it goes, and at the exact same time be this immovable object that just stops everything dead in its tracks? Sounds totally impossible, right? Well, that's the very puzzle we are going to unpack today. All right, to really get why the new discovery is such a big deal, we have to understand the two conflicting scenarios first. Think of it as a tale of two realities. This is the quantum puzzle that physicists have been wrestling with for ages. Okay, so on one hand, you've got this mobile particle, an impurity, that's just zipping through its environment, attracting this little cloud of followers as it goes. But on the other hand, you've got a particle that's so incredibly heavy, it's basically locked in place, and its very presence disrupts everything around it. These are two totally different endings to what feels like the same story. So let's explore that first reality, the one with the particle on the move. The whole story takes place inside something called a Fermi sea, and it leads to this really cool thing called a Fermi Polaron. So what is a Fermi sea? Well, the easiest way to think about it is like a super, super dense ocean, just jam-packed with tiny fundamental particles. This is the stage, the setting for our whole quantum drama. To really picture what's happening, let's use an analogy. Imagine a huge celebrity, like A-list, trying to walk through a completely packed Times Square. That celebrity, that's our single impurity particle. And that massive crowd? Yep, that's the Fermi sea. Now, when that celebrity moves, they're not moving alone, are they? Of course not. They immediately get this cluster of fans and photographers swarming around them. And his whole group, the celebrity plus their new entourage, they start moving together, almost like they're one single thing. And right there, you've just pictured a Fermi Polaron. In the world of physics, that whole celebrity and fan cloud combo is what's called a quasiparticle. See, it's not just the original particle anymore. It's this whole new entity, and it's defined by that coordinated movement. And believe me, this idea is absolutely crucial for understanding everything from ultra-cold gases to the heart of stars. Okay, but what about the complete opposite? If the Fermi Polaron is this kind of graceful, coordinated dance, this next idea is more like a full-on system crash. It's called the Anderson orthogonality catastrophe. And yeah, the name pretty much says it all. Let's go back to that crowd in Times Square. But forget the celebrity. This time, imagine a giant 10-ton stone statue just poof, materializes right in the middle of everything, and it is not going anywhere. That statue isn't attracting a following. No, it's just creating chaos. The entire flow of the crowd is completely broken. Every single person has to permanently change their path. The whole system is just fundamentally, drastically reshaped, simply because that one unmovable thing is now there. And that, my friends, is the Anderson catastrophe. You have this massive, stationary impurity, and it causes the wave functions of all the surrounding particles, the thing that describes their quantum state, to change completely. The system's original structure just breaks down. And here's the kicker. It completely suppresses the formation of those Polaron quasi-particles we just talked about. It's a total dead end for them. So this leaves us with this massive problem. We have two very real, experimentally proven situations in quantum physics that seem to completely exclude each other. For decades, it was like they were two separate universes with absolutely no bridge connecting them. And this brings us right back to our main puzzle. How on earth can the universe allow a particle to behave like a mobile celebrity creating a polaron and an immovable statue that causes a system-wide catastrophe? They just feel like total, complete opposites. And for a really, really long time, this was a huge hole in quantum theory. Scientists had these two totally distinct models, but they had no unified framework, no single theory, to explain how one could possibly, maybe, turn into the other. They were just treated as two separate things, period. But that has all changed, and it's all thanks to an incredible breakthrough from researchers at Heidelberg University. They found the missing link, the secret bridge between these two quantum worlds. And get this, it all comes down to a tiny, almost invisible wobble. One of the researchers, put it perfectly. He said that their new framework finally explains how those celebrity-like quasi-particles can actually emerge, even in a system that looks like it should be dominated by the immovable statue. He said they connected, and I quote, two paradigms that have long been treated separately. And the solution is just, it's so beautiful and elegant. The old idea always assumed that the heavy statue particle was perfectly 100% still. But the new insight is that at the quantum level, nothing is ever completely immobile. As the particles in the environment shift around, that super heavy particle feels these tiny little motions, these little wobbles. And that wobble, no matter how small, is the secret. It's the key. It opens up this tiny but crucial energy gap. And that gap creates just enough breathing room for those quasi-particles to form. The wobble, it's the bridge that connects the two worlds. So, okay. Connecting a celebrity to a statue with a tiny wobble is a cool story, but why does this actually matter in the grand scheme of things? Well, because this isn't just about solving one little puzzle. This is like drawing a brand new, much more complete map for the world of quantum physics. The impact here is genuinely huge. First off, it unifies theories that have been walled off from each other for decades. It also gives us a natural way to explain how these different quantum states can actually transition into one another. But maybe most importantly, it hands physicists a powerful new theory to guide all sorts of future experiments into the very nature of quantum matter. We're talking about the foundation of everything from materials science to quantum computing. So at the end of the day, what this really means is we've gone from having two separate, conflicting stories to one single coherent narrative. Scientists now have one unified way of thinking about the full spectrum of how a single heavy particle can interact with and completely reshape its entire quantum world. And that kind of leaves us with this one big, fascinating final thought. If something that seems so small, so insignificant, as a tiny little wobble was the secret key to uniting two whole paradigms of physics, it just makes you wonder, doesn't it? What other simple, elegant truths are hiding out there, right? In plain sight, just waiting for us to notice.